Hi everybody, this is 5.2, second part of chapter 5. I hope chapter 5 is going well. It's not a really difficult chapter, so these will go quick. We're going to continue on with our exponential stuff. Got a lot of rules to cover. So let's start out with just the basics of exponents. Whoops, forgot to do this. All right, if I have an exponent like this is called the base, and this is the exponent, or here it's called, here we say exponent, but we can also call it power. All right, so obviously here we have the base is 4, the exponent is 3. So it's 4 raised to the third power. What does that mean? It means, just on this one, not 4 times 3, but 4 times 4 times 4. You multiply the base times itself this many times. Okay? So that's what an exponent is. Shortcut, shorthand notation. Here the base is the entire negative 3x. We want to raise everything that's inside the parentheses to the 5th power. Okay, so this time the base would be negative 3x and the exponent is the 5th, 5. All right, product rule. What does that mean? Well, there's a ton of rules with exponents, but the product rule basically says if I take two bases that are similar and they have powers, but they have to be the same base, I can add my exponents. Okay? So here, and this is a really confusing section just because sometimes it says do not simplify and sometimes it says simplify, but they don't really mean you to simplify. So it's terribly confusing. But here we have 5 squared times 5 to the 6th times 5 cubed. The 5 is the base and they're all the same. So therefore this is, for a shorthand way of doing it, we can just add the bases, or the exponents, to the same base. So we have 5 to the 11th power. So I know it says simplify, but it doesn't mean simplify in this way. Okay? So when we get these enormously big numbers, it doesn't want that. And I'm not sure what the threshold is, what they consider to be big or not. So this to me is a large number, so we'll leave it as 5 to the 11th. Okay, so put your base in, and you put your power in. Okay, so that's what it's going to want, not this. If you put this in, it'll say, although your answer is equal to the correct answer, one of those messages. All right, we need some more rules. Okay, so we have, first of all, that if you have a power raised to another power, you multiply those two. Okay? So what if you have more than one thing in the inside? Then everything gets the power. Here we have a 1 and a 1 on those, so it's 1 times m and 1 times m. Okay, so we're going to kind of use these in combination. So here, I'm just throwing these rules out. We're going to use all of these, but this one we don't quite use those rules completely. All right, so here we have a 1 on the outside, so we are using this rule. We're raising to a power and we're multiplying, but since it's a 1 on the outside, it doesn't really affect anything. But we are using these. So now what we do is we say it's negative 2x to the 4th times 7x to the 4th. So I can combine my multiplication. I'm going to choose to multiply those two. Negative 2 times 7 is negative 14, because I can always say numbers are alike. And then I'm going to multiply these two, because those are my bases are the same. I've got x to the 4th and x to the 4th, right? So that would be x to the 4 plus 4, which is x to the 8th. All right, so that's just straight multiplication, which is addition. And you can look at it this way if you want to. All right. 8 to the third plus 8 to the eighth. Obviously that can be simplified, but again, it's going to be this enormous number, so they don't want it, and that's not the kind of simplification they're talking about. So yes, we have the same base, but now we're adding. That's kind of like adding an x and an x squared. Can you add those? No, they're different. They're not similar terms. So same thing here, you can't add these. They have the same base, but they have different powers. So this one can't be simplified. Now if this was multiplication, you know, obviously, now, oops, that's supposed to be an 8. Now we can say, yeah, that's 8 to the 24th power. Or, excuse me, 8 to the 11th power. We add exponents, right? But not when we add them. So this one can't be, this one cannot be simplified. All right, so now we're going to go back to this rule right here. Powers of powers is multiplication. Okay, so 6 to the 8th raised to the second power would be 6 to the 8 times 2, which is 6 to the 16th power. Now again, too big of a number. Huge, huge, huge number. So even though it says simplify, it doesn't really mean to simplify. So I'm going to check these because I want to make sure that we've got, that I'm giving you the correct information here. So 8 times 2 is 16. Leave that alone. Look at how large this number is. But then when they do 2's, they want you to put that into a number. I mean, this is like 2.82 times 10 to the 12th. It's enormous, so they don't want those in there. Now this one's smaller. This one, we're going to use the combination of these two things, right? Powers of powers, but we have more than one thing in there. All right, so let's see. We've got 3x raised to the 4th power. I'm going to encourage you to put your powers on there. This rule here, now take a look at this. This rule here says you take the power and multiply it by the power. It does not say you take the base times the power. This is not a 12. This is not 3 times 4. It's 1 times 4. It's power times power. And then we have x to the 4th. Do you see how I'm combining this with this? Now 3 to the 4th is a smaller number, so it might take it. 3 to the 4th is 81. So let's see if it'll take a smaller number in here. Because on some of these, see, now it'll take that because 81's much smaller than that ungodly big number that we had before. Some of these smaller ones, it'll take it both ways and some won't. So you just kind of have to play around with it. Now if you're having trouble on the quiz or the test knowing and you have an equivalent problem, please email me and let me know that, yeah, you weren't quite sure what was going on as far as the absolute form that they were looking for, and I will check it and give you credit for it because these are tough to know what it wants. So you really have to let me know. Okay? All right, so more than one thing. This thing has 3 things on the inside. And again, I want you to put your powers on there. Not 5 times 3, but 1 times 3. So this is 5 to the 3rd power, x to the 3rd power, y to the 3rd power. Now 5 cubed is 125, so I'm sure that that's, no, see, it wants it this way. This is multiple choice though. Is there more down here? Yeah, there is. So we're here, 5 cubed, x cubed, y cubed. Okay? I like multiple choice. All right. Now this one's a little different just because it has the 2 on the outside of the parentheses. So we have a q and an r raised to the 5th power. Now this is very different than this. This means the 2 gets the 5th power and the q and the r. And here it says, no, we want to multiply 2 and then we have each piece on the inside gets those 2. So this is different. This one would be 2 to the 5th, q to the 5th, r to the 5th. This is 32. So this is not what we want. We want this one here. Okay? So we want a 2 and then a q raised to the 5th and then an r raised to the 5th. It doesn't want that 2 in there. Okay? All right. Okay, so we have this rule here where it says if you have two things multiplied, everything gets the power on the outside. And this is saying if you have two things divided, everything gets power on the outside as well. So we have another rule. Let's say we had something like that. Then everything gets the A power. Okay? So in ours, we have a quarter raised to the 3rd power. Now, does it say, it says a simplified fraction, so it doesn't, so we have to be careful about the directions. So that would be 1 to the 3rd power, right, over 4 to the 3rd power. Each one gets that. It's not 4 times 3, it's the powers that get multiplied. 1 cubed is 1, 1 times 1 times 1. And 4 cubed, now if you don't know what that is, you can use your calculator here. You're going to raise it, 64. So we have a 64th. So I'm pretty sure, let's double check that, a 64th. Yeah, okay. Now, we can always check it this way on a test. Even though it says not to do this, we could always do it this way as well. Double check and just use the calculator from the get-go, 1/64. So either way, we're supposed to use the power rules, but we can also use the calculator to check in a test situation. All right, so here we have this rule right here. Okay, it looks just like this, except we've got d's and e's. So that would be d cubed over e cubed, right? Each piece gets the 3rd power. I'm going to use my forward slash, and then I've got e raised to the 3rd power as well. Nice work. Okay. Same thing here. All right, every piece gets the 3rd power. Let's try this one. So we have a -2 x cubed y to the 5th to the 3rd. Put that 1 on there. We have a -2 cubed, 1 times 3. X to the 3 times 3 is 9. Y to the 5 times 3 is 15. This piece of it right here needs to get simplified. Let's just try putting it in like that. I'm just curious. -2, see, sometimes it'll take it and sometimes it won't. Oops, that's not what I wanted it to do. Yes, it is what I wanted to do. I thought I needed an exponent in there. Let's just see. Might as well play around with it now rather than on your homework, right? Nope, it took it. I bet it'll take it if you made that into a -8. I'll bet it works as well. All right, same thing here. 2 is raised to the 1st power. Multiply, 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 right? Well, let's try this one. This one's got kind of a combination of a couple different rules. I'll do as many of these as I think we need to do here. So this 9c is raised to the 7th power, and this 9c is raised to the 6th power. So really, that would be the same as 9c raised to the 13th power, right? So that would work. It also work to say 9 to the 13th, c to the 13th. That would work. And that 9 to the 13th, let's try something. Let's try 9 to the 13th. Again, I'm really leery about these because I don't know how it wants it, so we should really check these out. Oh, that one's okay. Again, 9 to the 13th is too large to put that in. It won't take it. It's just such a huge number that it doesn't like that. All right. Let's try this one. We would have everything raised to the second power, 3 to the first, right? M6, N5 squared. So that's 2 times 1, so that's 2. M, 6 times 2 is 12. And 5 times 2 is 10. See, now if I put that in like this, I'm pretty sure it won't take it. It's got to have the 9, M, 12, and 10, because it's a smaller number. Let's try it without and see, just for curiosity's sake, to see if it'll take it, but I'm really quite sure it won't. I think that's the one that I tried earlier that it didn't. Oh, it did. Proving me a liar. There was one in here that I tried doing that and it said, although your answer is equal, then just change that to a 9 if yours says that. Okay, what do we got going on here besides a mess? All right, we have 4x4y cubed z, and that's all squared, times x5y to the third power. So wherever you don't have powers, you put ones. That's your starting spot to remind yourself. So everything in this parenthesis is going to get the power of 2. Okay, so I've got 4, 1 times 2 is 2, x8, y6, z2. Okay, I'm multiplying all these powers by 2. And then I've got these multiplied by 3, so I have x15, y cubed. Okay, 1 times 3, 5 times 3. Now, 4 squared is 4 times 4, which is 16. And now these are same bases, aren't they? I can add my exponents with my rule. So I've got, what do I have here? I have 23 of them. And then I've got my y terms. I can also add those. I've got 9 of those. And z is alone. So I'm going to look for something that's the same as that. Where are we here? We're right there, aren't we? C. 16 x to the 23rd y to the 9th z squared. Nice. And be warned, these are the other three will be the 3 most common mistakes that you can make. So double check these. All right, let's take a look at this one. We have a bunch of stuff going on in here, right? C5, 3. All right, so remember that I have multiple things multiplication-wise, and I've got division, so everything gets the third power. So wherever you don't see the power on the inside stuff, you put that on there. And now just everything gets that third power. So 3 to the 1 times 3 is 3 to the third. X to the 9 times 3, 27. Y to the 7 times 3, 21. Come on. Z to the 5 times 3, 15. 3 cubed, if you don't know that, it's 3 times 3 times 3. Obviously it's 27, but you can also do this. So we'll say it's 27, x 27, y 21 over z to the 15th. That's as simplified as it gets. These are all different bases. X, y's, and z's cannot be combined in that way. Okay? And then this one's the same as the number 16, I believe. Yeah, that's the same. So here you're going to say, you know, drag this 3 through this set. So we've got, for instance, b cubed, c12, d6. And this one gets the 5th power, supposed to be 4 to the 5th, b to the 20th, c to the 25th, and d to the 5th. And then from there you're going to start multiplying, which is adding exponents. Okay? And here 4 to the 5th, they have turned that into 1024 because they're considering that to be a lower number. So that's about it for this one. Nice, short, simple. I'm going to be combining 3 and 4 together because those are very similar. So this shouldn't be too long of lectures for you. So hope that helped, and I will see you for the next one.